I think one of the key things is to just, especially in scientific pursuits, to always kind of challenge existing dogma, right? So this idea of humans are unique was kind of really prevalent across all domains for a very, very long time. And slowly, science has been chipping away at that. I'm Kevin Lee. I'm a 7th year PhD candidate at SCHESC in the evolutionary anthropology approach, working with Dr. Kevin Langergraber, and then also Dr. Joan Silk and Ian Gilby. We recently put out a paper on a project looking at the prevalence of depigmentation in sclera in chimpanzees and other mammal species. So for a long time, so humans are known for having this universal trait that our sclera are white, whereas our irises are darker in some form. So even if you have very light blue eyes, it is still darker than the whites of your eyes. So in other species, it tends to be that most animals have dark sclera, along with dark or light irises. It's often dark on dark, and so for a long time, people thought that because our irises are so different in coloration and lighting than our sclera, it helps us track each other's gaze, which allows us to do lots of things in terms of communication without having to actually use words, right? So mother and infants are able to help each other direct each other's attentions towards common goals and objects just by tracking each other's gazes. And for a long, long time, people thought that it was because we have white sclera that we're able to do this to an extent that other species can't. So it is clear that for humans, white sclera is the universal trait, which does not seem to be the case in any other species, as far as we know so far. But the assumption before was that no other species had a high enough prevalence for white sclera to matter. So what we decided to do is, so at Ngogo, because we have so many chimps, we were able to notice that several of our adults had completely white sclera in numbers that we couldn't explain away, whereas other study sites had previously. So whereas most other study sites of 40 to 80 or 40 to 60 chimpanzees might have one adult with fully white sclera, so you can just say, well, that's just a random anomaly, it doesn't really matter. But when you have 200 individuals and you start getting something like 10, 15 individuals all having this prominent of discoloration in their eyes, you can't really ignore it. So we decided to look more closely at it, and partly because I am really just into photography, so I was using my equipment to take lots of kind of really close zoomed in shots on all the individuals to help us with learning all the IDs of every individual so we can individually recognize them just by their faces. So we were able to compile a large photographic data set of more than 1,000 pictures of 230 individuals using a lot of my pictures, but also some archival pictures we've had of our individuals. And we systematically coded through every single eyeball that we could see in there to see how many of them have fully white sclera or other forms of depigmentation, that if it really was super critical for you to be able to track each other's gazes, any amount of color change in your sclera should help with that. So we also looked at things like having tan or off-white sclera as opposed to fully white, or just having patches of discoloration. Right, so there's lots of different ways that your gaze might give important information to others. Primarily in terms of social cognition, people have focused on that ability to direct, to let others know kind of indirectly where your focus is on, where your visual focus is on, to kind of signal to them that you should also pay attention to this. So this is things like being able to coordinate joint attention. So if you want everyone, if for whatever reason you can't verbalize it, so this could be things like if you're out hunting and if you say something that would be kind of scare away the prey. But if you can make sure that everyone's looking where you're looking and direct them in a silent way by them just being able to follow where your eyeballs are looking, that can give lots of rich information that helps with things like coordination and cooperation. It also, in social learning context, really helps if you don't. So language and our ability to use verbal language developed very late in our evolution, as far as we can tell. But social learning must have been happening well before that. So part of that might be by being able to help direct others' attention towards specific objects of interest, of locations of interest, or behaviors of interest. You can help guide, structure, and scaffold their learning. So it's a kind of indirect form of teaching by saying, okay, I want you to pay attention to this thing that I'm doing right now. And if I can do that with just by pointing my eyes, that's really meaningful. So that's another thing that we found in because we had such a large data set, including lots of really young individuals, we are able to notice that this seems to have a clear developmental trajectory to it. So really young individuals under 1.5 has a much, much higher prevalence of depigmentation. It's, I think in our community, it was something like 70% of them had some form of depigmentation, which by the time they reach like 3 to 4 to 5, a lot of them have lost that. So we were able to demonstrate that both cross-sectionally, so using data from different individuals across the different age classes to establish that the prevalence at each age class quickly drops down and kind of levels off to about 5 to 10% by the time you reach adults. But also because we were able to do this over a long period, we were able to track specific individuals as they grew up too. And we're able to see that for a lot of them, their sclera got more and more pigmented. So it got darker and darker as they grew up, but not for everyone. So it kind of gives us a clue so this kind of offers another kind of tantalizing hint at how it might have evolved. We weren't able to test it directly, but it could be tied to the fact that humans and lots of other domesticated species are thought to exhibit what's known as neoteny, so the retention of kind of juvenile traits into adulthood. And this is tied to lots of different developmental aspects of just kind of existence. It's tied to a decrease in aggression. In animals, it's commonly tied to like depigmentation of different parts of your body. So the fact that we have like piebald cows or dogs, like all those weird patchy colorings in lots of domesticated species is thought to be tied to this because they were selected for non-aggression and to be domesticated. So there's clearly something there. The depigmentation of your sclera could be tied to all these other developmental depigmentation. Then it offers us potentially an idea of how humans also came to have it. Part of the study was also to go to the various New York zoos, and Izzy and Tucker, two of the co-authors, spent a lot of time photographing various mammal species at different zoos. And they were, out of, I think, 70 species, were able to find that at least 19 of them had at least one individual with white sclera, which is much, much higher than people thought. If you go from saying that humans are the only ones to have this trait, to now saying as we look at more species and more individuals, we are finding more and more evidence that at least some individuals have it. Then we have to rethink this starting premise that humans are the only ones to have it. One of the key things would be to try to establish whether or not having this depigmentation for wild chimpanzees makes a difference in terms of the way they're able to interact with others in the community. That is something that we are aspiring to be able to do, but is incredibly difficult in kind of the natural conditions that we're under, because we don't interfere with their actions at all. It's completely observational. So the amount of data that we would need to kind of establish any sort of functional ties to this depigmentation is a bit difficult. But there are lots of efforts, and there's ongoing efforts by other researchers kind of studying that more closely in controlled experiments. And so that has been a resurgence in the last few years, looking at the functional relevance of pigmentation in eyes. But one of the things that we're really interested in, that we're hoping to be able to do next, is to look at how heritable this trait is. right? So if your parents, or if at least one of your parents had depigmented eyes, are the offspring also more likely to have it? So because we have extensive pedigree and genetic data for all individuals in our community, that is something we are hoping to be able to look at. I think one of the key things is to just, especially in scientific pursuits, to always kind of challenge existing dogma, right? So this idea of humans are unique was kind of really prevalent across all domains for a very, very long time. And slowly, science has been chipping away at that. It's clear that humans are special in certain ways, but we are not quite as unique in the various domains as people like to think before. And so, you just keep chipping away at the existing dogma. And it's just important to remember that just because everybody thinks it doesn't necessarily make it true. To always kind of think about alternative ways to look at the world, to help us improve our perception of what really is out there.